They were desperate to get the telescope built and flown.
Perkin-Elmer's own measurement showed discrepancies in the surface of the mirror, but this was never passed on to NASA. The telescope was declared ready for launch. A disaster waiting to happen.
The hopes and dreams of the world's astronomers were with us that day at Cape Canaveral.
Go ahead.
The last time astronomers leapt a factor of 10 in observing capability was when Galileo in 1610, instead of using his eye, put the telescope in front of his eye.
And liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
All increases in capability after Galileo were incremental. They weren't leaps of a factor of 10 until Hubble.
Mission Control, Houston.
Roger, roll, Discovery.
We thought, let's go, we're off to the races. Little did we know the time bomb that was ticking. Little did we know.
Discovery Houston, you have a go to open the doors.
After nearly 30 years of planning, on April 25, 1990, astronauts used a robotic arm to deploy the Hubble Space Telescope in orbit, 380 miles above the Earth.
Capcom, we have a go for release.
We concur, Charlie.
Mission Control Houston confirms the Hubble Space Telescope is released.
With the telescope finally in place, everyone was excited to see what it could do.
Make final adjustments before we get to see the clearest pictures ever seen in the history of astronomy.
Nose gear touchdown.
But when the first images arrived, they weren't quite what the scientists had expected.
When they first saw these images, they just assumed the telescope wasn't in focus. They tried to move the focus backwards and forwards, but the light kept being blurred, like it was always out of focus. It was really quite a shock.
We were very worried.
I just couldn't believe it. It definitely was a huge shock.
We're supposed to revolutionize astronomy. How is it that we can't focus this telescope? How is this even possible?
After weeks of investigation, horrified astronomers suspected something was wrong with the mirror.
This is my logbook that I kept during the early days of Hubble. Daily we went to meetings and we kept a record of everything that was happening. Here's a particularly interesting day. We were told about the actuators on the back of the mirror. The actuators might be able to fix small errors in the surface of the mirror by pushing and pulling on it. So this says 1/2 wave is 7 times the dynamic range, meaning the problem is 7 times worse than they could fix. And here's a little note I wrote. This is the moment we find out that we are doomed to failure.
Sandra Faber and her colleagues realized that the problem was massive and lay at the very heart of the telescope.
The Hubble telescope has a big primary mirror that collects the light, and then there's a secondary mirror which reflects the light back down to the detector. So if everything is working, every zone of the primary mirror should come to a focus at exactly the same location.
With a single focal point, a star would appear crisp and bright. But this wasn't what was happening.
As I looked at those star images, I could see that the problem with Hubble was the rays are coming to a focus at different points. And that is the classic problem called spherical aberration. This